Alright you guys, welcome to video E3.4-10 for the Towering Toothpick Disaster Project, where we will be researching, designing, and building a earthquake resistant design type of structure. So the focus is what, features on a building will help make it earthquake resistant. We're not talking earthquake proof. It is not possible, at least yet, but earthquake resistant. So the first thing you need to do is to, you've already done the notes on earthquake resistant structures, and you need to then start moving through that packet. A lot of those terms that you see on the front of that packet perhaps will be very important. You'll need those to be able to talk about and explain the features that you are incorporating and why you are incorporating them. So I first want to look at this. After you get through that packet, which will tell you some ways to build, some things to think about, a little bit about earthquake waves, you are expected, absolutely expected, to go through that so that you understand that information. Okay? You are going to have to work very hard in your group to get to where you need to be. So, earthquake resistant buildings. This is a diagram that you will find. You will find it very easily in Google Images, and it tells us all sorts of things here that could be used, all of which you will learn about. We are focusing really on C here, describe the effects of earthquakes and volcanic eruptions on humans. But when we get into really talking about or testing our towers and talking about what waves they might have withstood, we're kind of back to B here. Okay, E3.4-10, talking about our different seismic waves. So first off, some examples. There's lots of examples in society of buildings that are built with earthquake-resistant features. One of the best here is the Transamerica building in San Francisco. You've already seen this in one of the prior videos, but in regions where earthquakes are very common, they need to build buildings with these things in mind. Just as you look at this building, you can see a pyramid shape. You can see a shear core, a shear wall here. You can see the reinforced base, the cross bases on the bottom, all sorts of stuff. Back in '89, it swayed 1 foot at the top here from side to side. 1 foot it was moving as those earthquake waves moved through this tower. Pretty incredible. The John Hancock building in Chicago actually also has these cross braces. And if you've ever been inside that building, you can see there's a restaurant way up here at the top. You can see the beams, or those cross braces, sorry, going right through on the inside as well. They're part of the structure inside. This is right downtown on Michigan Ave, the Magnificent Mile in Chicago. So for this project, we're going to kind of research those, and the websites are, there's a link in the lower right-hand side of our class website for E3.4, for that unit, which will take you to all those websites that you have listed on your sheet for researching. You do not have to type all those in. So, for day one here, you've gotten it. You've gotten all your info. I'm introducing it. I'm going to talk about the materials here. I'm going to talk about what needs to be incorporated into the building, and that is also in your packet. You should find it and highlight it probably. Or just review this video. It's up to you. I personally would probably highlight that info so I didn't screw it up. I'm going to talk about the timeline, and then we're going to get going on your research. So, day two, finish your research. You got to make a plan here of how you're going to diagram this, and you're going to begin drawing your diagram. Okay? To begin drawing your diagram, you're going to come up and you will get 3 pieces of graph paper like this. Every person needs 3 pieces. Every person in your group, ideally that's 4 people, so you're each building one side. You're going to want to build this to scale so that you have a template. Okay? And you're going to attach this graph paper in whatever way you need to be able to draw this diagram to its certain specifications. But this is what the graph paper looks like, and you're going to get 3 pieces each from me. Once you finish drawing your diagrams to scale, you are going to also do an explanation. It is on this sheet. And you each are going to do this. Okay, so if our learning target is E3.4-10, describe the effects of earthquakes and volcanic eruptions on humans, we're talking about earthquakes in this respect. It says, in this part of the project, you're required to provide written support of your diagram. This will need to outline the qualities and characteristics of the diagram, which will make your building earthquake resistant. It says, be specific and be thorough. You should discuss the following features of your building. You need to talk about the base, the columns, the beams, the cross braces, and any other features then that you're adding in. But I need to hear you talk about at the very least, these listed. And probably to get approved, you're going to have to go above and beyond that. Okay, that means approved to start building. So you have the explanation done, your diagram done. If it's good and everyone's on the same page, meaning they all look exactly the same, we're going to get approved, and I'll let you get your materials. Then it's build, build, build. Okay, I'm giving you roughly 3 days here. That is plenty of time for you to build one side and put this sucker together. And then so on that final day, we're going to go ahead and test it. And then as you're testing it, I have some more handouts that you'll get. Really just one that you fill out saying, hey, I made it through this wave, or I didn't, and here's where it broke first. Okay? And that's maybe one more place where we can use an iPad to sort of video instead of just guess where it broke first. That might be kind of neat to see where it failed. But then also, there's some final discussion questions to go with this. And we'll talk about how that may or may not count for a test grade when we get there. So, here is the very important construction criteria. Buildings must be 45 centimeters tall. 45 centimeters tall. Okay, that's not that tall. You saw the samples of buildings. That's roughly 1.5 feet. 1.5 feet tall. Okay, but we're in science class. We're measuring centimeters. 45 centimeters tall. It can be taller. It has to be at least 45. You're going to have at least 3 stories, which means each story must be 15 centimeters high. So you can't have your first story until you're 15 centimeters off the ground. Each story has to have a floor. Now, not a floor like we're thinking. This tower is mainly just the infrastructure. If you saw a skyscraper being built or something like that, where they're just using the steel beams and columns first, that's what we're building. Okay, it's just like scaffolding. It's the bare minimum. A floor can be one stick going across your diagram or across your tower. Okay, at 15 centimeters, at 30 centimeters, at 45 centimeters. Right? It is not, and it cannot be a solid floor. A flat roof, again, at the very top, wherever that is, it has to be flat. Okay, we're not going to make it pointed. One, this saves time. You can narrow things as you go up if you choose to do that, but it still has to be flat at top. Buildings cannot have solid walls. Instead, the structure should be more like scaffolding, as I've said. Here's an important piece. It says the footprint, okay, or each side. Each side can only be 22.5 centimeters. Okay, it should be exactly that, from side to side on the bottom of your tower. The reason is it has to fit on this board right here. Okay, I'm going to take this foam, and you can see on the other side, I have some holes kind of drilled out where this is going to go into. Okay, let me back up. I got my earthquake shake boards that I pointed out to you guys. On there is a base isolator system already. You'll learn about that. Okay, you don't have to build that into your tower, but these are going to sit over those screws that are part of that base isolator system so that your tower can move independently. The base isolator system is something we're giving you in this project. That's a very important aspect of earthquake-resistant designs. A base isolator system that allows the tower to move independently, somewhat, of the ground around it when an earthquake is moving through. Okay? Very important. So we're giving you the base isolator system. We need to take your tower and basically we'll be duct taping it to this. So it will be attached to this sucker on the bottom, and then we'll attach this sucker to the base isolator. Okay? So, a few things. You'll be given one of these cups. One of these cups to put glue in. Okay? We'll probably give you, since you have 4 people in your group, 2 cups, each half full. That's all the glue that you're going to get. We are using a basic wood glue. This is Tight Bond. And wood glue bonds very strongly. When you're working with wood and you're using glue, generally your glued joints are stronger than the wood itself. Okay? But you only get a certain amount of glue. We also have wood splints. Okay? You can see that these are longer and thinner than regular old popsicle sticks. All right? So popsicle sticks, wood splints are your main building materials. You will get a certain amount. Okay? You do not have to use them all, but you do not get more. Same thing with the glue. You do not get more. So be careful how much you're using. Okay? You can cut these also. You're going to need to be cutting them. We cut them with either these suckers. You can see right here, I can cut a piece of wood. Or these angle cutters right here. It cuts the wood well. You might have to squeeze it kind of hard. But here's a caution. If I'm cutting this sucker, that little piece that I'm cutting off is going to come flying off of there. So it is very important that I point that towards the ground when I'm cutting it. I'm holding on to one piece, I'm pointing it towards the ground to cut it. If I catch people flinging these things around the room, you are immediately done. You are done with this project. Okay? This is something that if it's flying through the room, could hit somebody in the eye, and then it's bad news for you. Real bad news for you and that person. So, be careful with the pieces that you're getting rid of. You are responsible for cleaning up all wood pieces at the end of your work time. We then also have some toothpicks. People generally don't use these a whole lot. Sometimes they just use them to help glue. They'll put some glue on the toothpick in, and that's how they'll spread glue maybe onto these sticks to make a joint or something like that. Or maybe they're making a joint like this. There's examples in your packet. But they'll use the toothpick to spread glue on these suckers so that they're not wasting glue. Remember, with this glue, a little bit goes a long way. Okay? We will also have Q-tips available to help spread glue. Just remember, you might want to pull some of that cotton off the end of the Q-tip because that's just going to gum up and absorb your glue and waste it. So for clamps, I have paper clips, and I have lots of paper clips. And if my paper clips disappear, if you're bending them into little toys to shoot at people, like springs, we're going to have a big problem. Okay? These are for clamps. Because if you're doing that, you are misusing lab material. So I might glue it, clamp it, and then I need to set that aside to dry. Okay? But paper clips will work very well as a clamp system. Okay? You might need a few on there. I don't know. It's up to you. But paper clips work well for that. With that being said, those are all our materials. I will get out the shake boards so that you can sort of check them out and see exactly how this foam board is going to attach to it before you start building. But one, you're going to read through the packet. Two, you're going to research the sites using the link at the E3.4 unit website. Should be in the bottom right, or I think there's actually one at the very bottom of the page. Three, you're going to design your building. Then you're going to get it on paper, write an explanation for it, and get it okayed by Mr. A and myself. After that, you can start building. All right, everyone in your group should be working together on this so that you are all on the same page, and when you slap all your sides together, they work. Okay? If you have any questions, please come ask Mr. A or myself. We'd be happy to help you out here.